You bought the best GPU money can buy, yet your AI feels slower than it did a week ago. You feel like you need to spend more on hardware to fix this lag, but that is exactly where the trap lies. The reality of modern large language models is rarely about raw calculation power. It is usually a mismatch between memory bandwidth and compute utilization. Today, we connect that frustrating feeling to the engineering trade-offs behind data movement bottlenecks. When you look at benchmarks for AI hardware, they often focus on flops, which stands for floating point operations per second. This number tells you how fast a chip can crunch numbers if it already has them in its immediate reach. But in practice, adding more GPUs to your cluster frequently yields diminishing returns because the bottleneck shifts away from calculation speed and toward data movement. This is known as the von Neumann bottleneck. It describes a situation where the processor sits idle waiting for information to arrive, much like a high-speed engine running out of fuel. Consider the frustration many developers face with cloud configurations. A study conducted by researchers at Georgia Tech identified that modern LLM serving stacks often suffer not from GPU saturation, but from CPU starvation. Cloud providers frequently underallocate central processing unit cores to users as a cost-saving measure. They might assign only 8 cores to handle data for a cluster of powerful graphics cards. Since the CPU handles critical pre-processing tasks like tokenization and kernel launches via schedulers, the expensive GPUs sit idle waiting for instructions or tokens to arrive from that limited number of cores. The engineering impact here is profound because it changes how you should approach system design. Adequately provisioning these central processing unit resources can reduce time to first token latency by a factor ranging from 1.36 times up to 540 times. This often happens at a fraction of the cost of simply adding more GPU instances to your infrastructure. The lesson is clear. You are likely not facing a lack of raw flops, but rather an architectural mismatch where data cannot move fast enough to keep the silicon busy. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This phenomenon explains why users with top-tier hardware can still experience severe latency spikes comparable to low-end setups. For instance, reports from major platforms have shown that even devices equipped with massive memory capacity like 108 gigabytes of RAM on M5 Max chips can see simple tasks take 10 to 20 minutes to complete. In these cases, the bottleneck was identified as systemic data movement issues and context compression routing problems upstream, not a local hardware exhaustion or lack of raw power. The problem extends beyond just cloud configurations into specialized accelerators as well. Even dedicated neural processing units designed for efficiency can appear slow due to software inefficiencies rather than physical limits. In documented cases involving the Intel NPU utilized by OpenVINO plugins, these chips have been observed utilizing only around 20% of their capacity, while the central processor consumes over 80%. This indicates that poor driver optimization or kernel launch overhead is starving the accelerator. The hardware itself is capable, but the software stack fails to feed it effectively. This creates a situation where engineers chase bigger chips as a silver bullet for latency issues when the root cause lies in system design choices. You must stop assuming that buying more silicon solves every speed problem. Instead, you need to audit your CPU core counts relative to GPU instances in cloud configurations before making any purchasing decisions. Often, simply balancing these ratios yields better results than chasing the latest hardware release. There is also a psychological layer to how we perceive this slowness. Behavioral research suggests that when users treat an AI system as predictive authority, they may subconsciously tolerate or misinterpret latency differently. In experiments involving over 1,000 participants, roughly 40% treated the AI output as authoritative guidance over their own judgment. This perception can alter how speed and utility are evaluated by humans, but it does not change the engineering reality that without efficient data movement, performance degrades regardless of user expectation. The statistics on this effect show a measurable impact on decision-making. When users view an AI prediction as authoritative, they face odds 3 to 9 times higher for going to greater lengths than necessary compared to those who do not treat it with the same level of trust. This can lead to earnings reductions ranging from 10.7% up to 42.9% in scenarios where human operators relied too heavily on biased or slow AI inputs without verifying the underlying system health. The solution requires a shift in perspective from asking how many chips you need to asking what architecture actually moves data efficiently. When troubleshooting slow inference, check first if your GPUs are truly saturated or if they are idle waiting for data and input-output operations. Look at memory bandwidth utilization rather than just clock speeds or flops ratings. A slow AI experience is frequently a signal of architectural inefficiency in the software stack or misconfiguration, not necessarily insufficient compute power. Solving this requires system design changes that optimize how instructions travel between components. You must prioritize balancing CPU allocation and optimizing tokenization pipelines to ensure your expensive silicon never sits idle waiting for work. By focusing on these data movement bottlenecks rather than just raw flops, you can achieve significant performance gains without the need for costly hardware upgrades or chasing every new release in the market. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.